Hello everyone, my name is Devashish and this is an Ed Sharpener production. This video is the solution video to the spider reaching the opposite end problem that we discussed few days ago. And the problem is there is a spider at one end of a cube. Spider, I'm drawing it like spider. Okay, so let's name this end as A. And the problem is that the spider wants to reach at the end B, and the condition is that it cannot travel through the space. All right, so I would like to thank everybody who answered and have taken time to solve this one. So we will first discuss the calculus way of solving this problem. So all right, how we can do this is first realizing that in order to reach B, we anyway will have to reach either the blue wall or the yellow wall if you are at point A, because the blue wall and the yellow wall directly connect the point B. So traveling through the green plane anyway we'll have to reach either of the two walls, and then we can travel up to B using the straight lines. So let us draw two straight lines. Let's say this is the distance that we cover to reach the blue wall, and then from that point we reach the point B. I'll name these points for the convenience. So let us say this is point C, and let's say this is point M, and let's say this corner is N. So this is the generalized way. So let us consider this distance as x. We already know that each side of the cube is of a length. Now let us find out the total distance in terms of x. So the distance that the spider traveled is AC and CB. So AC plus CB is the distance that the spider is going to travel. So AC is going to be the square root of a square plus x square, since AM and CM are perpendicular, and so AMC is the right angle triangle. So we do have that right angle triangle and we can use the Pythagoras theorem there. Similarly, we can find CB by applying Pythagoras theorem in the triangle BNC. While BN and CN are the perpendicular sides, CN is a minus x. So CB is going to be the square root of a minus x square plus a square, which is the length of BN. So let us say this is some distance s. Now we simply have to minimize it. So calculus says if you find out ds by dx and equate it to 0, you get a point x where you will have a minimum or a maximum. Alright, so let us find out ds by dx. So if you apply ds by dx for the first term, you get in the denominator 2 times a square plus x square, and using chain rule in the numerator we will have 2x, plus for the second term if you differentiate it, you get in the denominator 2 times square root a minus x bracket square plus a square, and using the chain rule we have 2 a minus x and minus, and let us equate it to 0. So first let us cancel out those 2's in the numerator and in the denominator. We are left with x divided by square root of a square plus x square, and let us shift the other term on the right hand side. We have a minus x divided by square root a minus x bracket square plus a square. We can also write this as square root of a minus x square plus a square divided by square root of a square plus x square is equal to a minus x divided by x. If we square both sides, we get a minus x bracket square plus a square divided by a square plus x square is equal to a minus x square divided by x square. Now focus on the first ratio. We can write that ratio as a minus x bracket square plus a square divided by x square plus a square. And now focus on this part. So this ratio a minus x square by x square and a minus x square by x square. If you remember the theorem on equal ratios, if you have, let's say, m by n is equal to p by q, you can also write this as m plus p by n plus q. So let us compare this ratio with the last one and the first ratio with the first one. Okay, so p by q is simply nothing but a square by a square. All right, so what we can write is a minus x bracket square divided by x square is equal to a square by a square, which is nothing but 1, and therefore a minus x divided by x is equal to plus minus 1. Now if we solve for x using minus 1, we get a is equal to 0, which is not the case. We will have to use 1 on the right hand side. So ultimately we have a minus x divided by x is equal to 1, and therefore a is equal to 2x, and therefore x is equal to a by 2. So at x is equal to a by 2, we are going to get the minimum distance. If you put x is equal to a by 2 in the original form, so we get s is equal to square root of 5a, and that is the minimum distance. Now there is another very elegant approach, that is unfolding this particular cube. Why I say unfolding? We already have the condition that it cannot travel through the space. So there is no point in keeping this cube in 3D because anyway we are traveling on the surfaces. So if we unfold this particular cube, we will have to look at the distances in a single plane, and we can deal with the distances in a particular plane very easily. So if you look at the cube from above and unfold it, so this red wall falls like this and the blue wall falls like that. So the unfolding looks like this. So if you unfold this particular cube, this is what it looks like if you look at it from above. Now let us try to trace where are our points. If you match the square, so basically this is the front face which is colorless, and this is the top surface. So these two were not colored. So front and top are like this. This green is the base here. The red wall falls on the right, blue wall falls on the left, and the yellow wall falls like this. So this is our point A. Now look at where should be the point B. So this is where the point B is. So let's say this is B or this is B. These were the same points, but now they're split. So we can call any of them as B. And now we simply have to travel from A to B. We know that the shortest distance between 2 points is the straight line. So what we simply do is we can connect A and B. Let us say this is the triangle that we get. Note that this point is M. So in triangle AMB, we have the right angle here. The length of AM is A and this length is 2A, isn't it? And therefore shortest distance AB is the square root of 2A square plus A square, and that is equal to square root 5A. And this is how you can actually get to the answer without using calculus. So sometimes just changing your perspective can simplify the problems for you. I hope you like the solution. We will see you soon with new video soon. तब तक के लिए ज्ञान पीते रहिए.